Hello Year 10, welcome to week 3 of physical landscapes in the UK, and this week we'll be looking at processes along the beach and in particular longshore drifts. We'll start with a little photograph. I'd like you to have a look at the photograph and think about why is there more sand built up on the left hand side. So pause the video here and have a little think about that question, and we'll come back with an answer at the end of this week's learning. So you will need reference to the textbook for notes and things this lesson as well, in particular pages 96 to 97. So we're going to be looking at how mass movement can actually occur along the coast through a process known as longshore drift. So we're actually going to describe and explain how material is transported along the coast and what kind of physical features that can create at the coast. So first of all, I'd like you to turn to page 96 of the textbook and have a look at some of the processes of coastal transportation, please. You'll see there is solution, suspension, traction and saltation. It would be worth drawing diagrams for all of these, but before you do so, have a look at the diagrams on here and the descriptions. What I'd like you to do is pause the video here and have a go at matching the definitions to the diagram. Let's see if you were correct. So we've got suspensions, which is particles suspended or carried within the water. You've got solution, which is the dissolved chemicals that have actually dissolved the rock, for instance chalk, which is highly susceptible to chemical solution. You've got saltation, which is a hopping or bouncing motion of your pebbles, usually along the seabed. And then you've got traction, which are large pebbles that are actually rolled along the seabed, but that takes quite a lot of energy in order to move them. So make sure you have a good diagram and definitions written down for these 4 types of coastal transport, please. So we will look at deposition. Now deposition, or to deposit something, occurs when material that is being transported actually is suddenly dropped, and it's usually associated with the sea losing energy. So I want you to think about when deposition is most likely to occur. So usually this will occur when waves enter a shallower area of water and lose their energy, or when they enter a sheltered area like a cove or a bay, where the wind drops, so there is less fetch, linking to last week's learning, and also there needs to be a good supply of material in order for it to be dropped initially. So I want you to have a look at the diagram here for diagram C. So what you can see here is something called wave refraction. Now, as waves approach a headland and bay formation, like you can see here, a lot of the energy will be directed towards the headland, which is the more resistant area that you can see. Then the energy of the wave is then transferred or refracted into the beach areas, the bay areas, and they slow down there, so it allows for more material to build up. So that's why they're usually quite sheltered areas with substantial beaches there. So I want us to have a little look at this process of longshore drift. So on your PowerPoint version of this video, you can obviously open the link there and watch the short video that will describe this. But longshore drift is a zigzag motion. So where your swash, which is your upcoming waves, will come up the beach at an angle, but then will actually return the backwash at a right angle. So what will eventually happen is that the material will be moved along the beach, and whilst it's moved along the beach, it will also have erosional processes working on it to make the material much smaller and much rounded as it does so. So you need to draw this diagram in the book, and that is one of the activities for when you get to that point. So it's worth having a drawing this diagram. Now the direction that wave will actually hit will depend on the direction of the prevailing wind, so where the winds are actually coming from, and obviously then the swash will come in with the wind, but then will return at a right angle. And the whole while, think about that image we looked at the beginning of the lesson with the groin and the material build up. So have a go at this one. You can pause me here. These statements explain how longshore drift occurs, but they're jumbled up, so I'd like you to think about what order they should actually go into. So So here is the correct order. So the prevailing winds cause the waves to hit the coast at an angle, they move up the beach, swash, and then backwash pulls them back down at a right angle, and then this keeps occurring and moves the material along the coastline. So have a little look at this OS map, this Ordnance Survey map. What do you notice about this map that might be connected to longshore drift? Have a little look. Well, firstly, you can see a lot of deposition, can't you, there? You can see the sands and the mud flats there. But you can actually see this feature which is associated with longshore drift, which is known as a spit. Now, there's a video attachment here that you can obviously pause the video and watch, pause this video and watch this video on the formation of a spit. But basically, if you imagine, as longshore drift is coming in as swash at an angle with a prevailing wind, returning at a right angle, it's moving the material along. And where there's a sudden change, like a headland or a sudden change in the coastline, the actual process of longshore drift will carry on, and you end up with these sort of long, like finger-like landforms known as spits, which are just extensions of the coastline, just made of sort of sand and pebbles and deposits. And you'll notice that they can actually recurve or curve at the end if there's an alternative wind direction hitting them. And often behind these spits, they're quite sheltered, so you will get salt marshes behind them. Very interesting, and we'll come back to this, but do watch the video and you can make a few notes on this formation associated with longshore drift. So we bring you back to that image we saw at the beginning. So why is it building up? So if you can imagine, the beach is much higher there on the left-hand side, and then there's a huge drop on the other side. So actually, the longshore drift is coming in and depositing the material, as you can see, and then preventing the material from being moved along the beach. I want you to have a think about why that might be. Imagine if you never stopped the material from moving up the beach, you would lose it eventually. And obviously beaches are tourist attractions, and you need sand and deposits obviously there too. And also a wider beach actually protects the land from further erosional processes. So I'd like you to have a little go, please, at the activities and the practice questions. There's also a stretch yourself question. So you'll find these on page 97. So have a think about how this connects to last week's learning as well. Make sure your notes are incredibly detailed, and you can use my model answers provided to help you with activities 1 and 2 and the practice questions. So good luck with this, guys, and I will see you on our Teams meeting chat this week. Thank you. Bye.